Hello out there. Today's project is to get this bad boy grinder hooked up to the main line. So it's kind of been sitting idle here since it was restored, but it would be a big benefit to be able to sharpen the bits for the lathe and the drill all in-house. It's a very simple unit, just has a shaft and a fixed small pulley. There's no driver idler on this, and that's why it needs a countershaft, which is what I'm going to build today. It has babbitt bearings, the oilers are in the back, and coarse wheel, fine wheel, pretty simple, like a modern one. So there's two rafters on the roof that I'm going to use, and because of where they are, the line shaft, the countershaft is going to be a little bit different than most. So I have a couple hangers ready. These are the early style curved hangers, and they support the bearing from the sides. The main line hangers are all top and bottom support. The benefit of top bottom support is you can have split bearings, self-oiling split bearings that you can take apart, and you can set them up anywhere along the line shaft. If you have a side support bearing, it doesn't have any pieces that can come apart, so you have to slide them down and kind of plan where you're going to put them. That's all well and good, but if you ever want to modify where they are, it can be a pain because you have to take the pulleys off, slide everything off the end, and realign it. Anyway, it's fine for countershafts. They don't have as much adjustment normally as the top-bottom support because you have screws that can raise and lower. The only adjustment on these ones is a pivot, kind of an angled up and down pivot. There's also elongated slots so you can shift them a little bit to make up. There's a boss in the bottom that you can drill and tap and put a catch tray on for the oil. These didn't come with any bearings, didn't have any. The original bearings were kind of these cast things that had a deeper inside and then the outsides got narrower, but we can approximate that just with a thick-walled tube. So that's what I'm going to do. This is 4-inch sections of approximately 2-inch outer diameter thick-walled tube. I've gone ahead and drilled either side, which will mount to the pivots in here. A set screw just goes in to lock it. And then there's a hole in the top, which is where the oil will go in. And we will do the babbitt pouring today as well. The pulley setup on this counter shaft consists of a driver and an idler, these two small ones, and then the driving wheel, which is belted to the machine. Because of how the rafters are set up, this wheel has to go on the outside of the farthest, what would that be? Your right, the farthest right hanger, and then these ones will go on the middle like normal. So most counter shafts are somewhat easy. You just need to put the driving wheel and then the idler and driver. When you fix them, they act as the collars, so the shaft's end play is limited. In this case, because this pulley is going on the outside, and where the driver and idler have to line up, you can make the innermost will be fixed to the shaft. That'll be the driver, and then the idler will just spin in between the fixed one and the other bearing. So that limits end play that way, but the whole thing can still slide out. So I've gone ahead and also machined a little collar to go on there to limit the other direction. So one collar and 3 pulleys. The 2 smaller ones needed to be bored out. The larger one was approximately 1 1/8, which is the size of shaft I've gone with. And everything here is kind of necessity builds because you can't really go to the pulley store and get whatever size you need. And shafting and hangers, it's all make do with what you have type affair. So I'll add some clips of cutting the shaft on the hacksaw and drilling on the drill press, and we'll go ahead and pour the babbitt and mock everything up. Once it's mocked up, everything's good. Sandblast, spray bomb, the same sand color, and fire it up. These pulleys, the size is going to be what they are, but the pulley on the main shaft, I have a few, so we can change that to change the speed of this lad. This big fella should be running at somewhere between 3,000 and 4,000 RPM. I'll be happy with that. Any more babbitt bearings, I don't know in this case, but yeah, let's see. Go ahead and see. All right, so here's the babbitt pouring setup. This is the shaft that will be used for the countershaft, 1 1/8 inch. And I've slid a piece of standard printer paper over top of it and taped it. So if you watch the last video I did on babbitting for a bandsaw, it was a similar process. The paper idea comes from my buddy Andy Sharp, who runs Canadian Woodenware Company. They have a big line shaft driven wood shop. So that just greatly reduces the time in scraping, and none of this stuff is really overly precise. So that little bit of difference between the shaft and the babbitt will let oil get in and save time. So this little wooden plug is just blocking the oil hole. It's not too tight, so I think I'm going to take out the good old paste, the Moonshiner's paste. This is just flour and water, and as soon as this shell gets hot, it's going to kind of bake on there and act as a seal. So they sell a damming compound that you can use to do this when you're doing larger jobs, or when you want to lay down a shaft, put collars on it. That's what they use, damming compound, but this is the cheap and easy way. So I'll just line that up by eye. The shaft is as vertical as I can get it, and this piece of wood is just a 2x6 planed with a 1 1/8 hole drilled in it, and it fits very tightly. So I'm going to line it up like so. Also, if you remember last video, the taped piece of paper, I used Scotch tape, and it bubbled along here from the heat. So I've tried masking tape this time. We'll see what happens, and I'm also going to line it up with the top where the oil is, so that if it does bubble, it won't be on the place where the most force is being applied. So go ahead and do that. Oh, there goes the clock. And that should be just fine. So we'll get the babbitt up to temperature and see. Maybe, oh yeah, it won't hurt to, I'll put paste around the bottom too, just to further seal it, even though it's the metal is flat and the wood has been planed, so it should be all right, but you never know. There might be forces pushing it apart. Same idea as when you do casting, you need to put weights on top, so won't hurt. Won't hurt to put some paste. Now that's not going to hold anything down, but if there's any single little tiny cracks that the babbitt gets through, which sometimes happens when the babbitt's really hot and it wants to flow, this should kind of cook into bread almost and stop that from happening. Here's the ladle in the forge, and I have some old babbitt in there, and I'll also add a piece of this 1 ingot of Mount Royal Montreal new old stock babbitt. Thanks to my buddy Paul for this stuff. I just kind of split it on the anvil and break it off and put 1/2 of this in. Need to get it warmer. So I'll let that melt and then go ahead and take the sludge off and gauge the temperature with the shim, and we'll be ready to pour shortly. Okay, it's getting there. I'm waiting for the wood to char instantly when I put it in. It's just kind of gently browning it at the moment. Okay, let's see how much of a mess I can make. Ah, that's the wood. Ah, geez. There we go. Damn. Well, we were close. So what you just saw there was a pretty typical example of a steam explosion. I think that probably would have been from the wood. A little bit of dampness, and when about it went down, steam couldn't escape, and it kind of threw the whole shell up a little bit, and then it leaked from around the bottom. So some was sacrificed to the floor and the workbench and whatnot. I've cleaned that up and remelted it, and I've melted half of that other Mount Royal Babbitt ingot, and I'm going to try, because everything stayed reasonably concentric and now the bottom's sealed, I'm going to try to pour again and let it cool, then take it off and see if the first little pour will stick to the second pour. If it does, then everything will be perfect and I can just leave it. And if not, then I'll have to do it all over again. Just scraping more of the grit off. Back up to temperature. Here we go. Hey, hey, calm down there. Ah. Woo-wee. Mm. Knock on wood, knock on wood, knock on wood. Gee whiz. Can you see that from your angle? Yeah, you can. So I guess the heat of this pour was enough to melt some of the bottom pour, and it leaked out ever so slightly. And look at what's left, just barely enough. So that worked out very well. My, that was lucky. Wah. Okay, well, if that melted out there, then I assume the fusion between two layers will be all right. But I'll need to let that cool and reanalyze in a minute. Okay, the thing's still warm, but it's cooled down a fair bit, enough to start playing with it. So there's a plug. That almost leaked. Not quite. Oh, geez. Where's the other glove? There's that. Singed, but I was curious if you could see a little burst where the water exploded. Anyway. Now, how's this going to come off? We're going to have to bonk it. Maybe. Now it's time for the second pour. The only thing I've really changed is that I put a heck of a load of paste around it this time and preheated it, so it kind of smells like bread in here now. Anyway, hopefully that seals it more, and then the heat of the previous pour maybe dried the block of wood a little bit. We'll see. Okay. Let's go. Mm-hmm. Wow. I'm not gonna watch it. I'll let it do its thing. Don't want to jinx it. Looking good though. Looking much happier than before. Well, I'll go ahead and let this one cool. Previous one, I needed to hammer the shaft out after letting it sit in water, so hopefully this one will be a bit nicer to deal with, but never know. Okay, I'll let it cool, we'll come back. So it's been a couple days since the last video clip, and progress has occurred. That is, the second bearing pour went much better than the first with all the trickling explosion and whatnot, and the shaft came out quite easily. And once that was done, it was painting time. So I sandblasted all the little parts, painted everything. You see a few hanging here. These are the shifting forks, the shifter bracket, and the collar that goes on the shaft, along with the two hangers. Lovely sand color, good to go. I made a couple new set screws using carriage bolts. These are just standard carriage bolts from the hardware store. And I cut the dome heads off and then kind of ground them and wire wheeled them to get the obvious zinc off the outside. And then there's a couple square nuts stacked as jam nuts. So both of these will go here. And oh, might need to chase the threads on this one. And it wouldn't hurt as well if I went to the grinder and made a bit of a cone shape on either one of these for where they kind of pinch the babbitt bearing. So I'll go do that right now. These hangers anyway, got some carriage bolts, big old carriage bolts and washers for them, and drilled a pair of holes in this cross member, which also supports one of the main shaft hangers, and then added another spruce cross piece, and it just has two threaded rods with plates on either side so that I can shift this cross piece along along this support on the far side, as well as move it in and out, which will allow the countershaft to change its angle with respect to the main line in the case that it isn't square. And that's kind of in addition to these groove notches. So we should have plenty of adjustment to work with. And yeah, I'll go ahead and put this one hanger up. Just throw the carriage bolt through there. These are 1/2 inch by 6. And the 1/2 inch carriage bolts, the squares on the bottom here perfectly line up with these notches. So you have about a 1/2 inch of play, and you don't need to use washers or anything, and that's what prevents the bolt from spinning when it's up here. So go ahead with the little eye for shifting will go outwards. Maybe I'll put the closer one on first here. Oh, that's going to be tight. Oh, wrong one, that's why. Okay. Nope. That one needs to be hammered, so the far one it is. The good old hand hammer does the trick on that one. The thing that I'm curious about here is once this hanger's up, the shifting lever, the wooden shifting lever, is going to just about overlap the shifting lever for the lathe. So I might have to kind of cant it backwards on an angle so that they don't hit when the lathe goes in reverse feed and when the grinder gets engaged. Okay, there we go. It's the first bolt of hanger number 1 up. I'll go ahead and get the second, and then mock up the shaft and lay it in there and then slide the bearings on. Or no, I know. Have to mock up the whole shaft with the bearings, then put it on. If you look, with the driving wheel that drives the grinder, I decided to go with a little pinstripe scheme, a black pinstripe, which was just done with a little paint pen, but I find that kind of draws a lot more attention to it. It's not too over the top, but draws a little bit of attention. I kind of picked up this scheme of the kind of the Y forks from a old steam traction engine pulley design. So, okay, I'll get those other hangers up and then we'll add the shaft. So the hangers are now up in their positions, roughly for now. They can still be adjusted, which means it's time to put together the shaft in its given order. So I'll start with the shaft itself, just a 2-foot section of cold rolled 1 1/8 bar. I have this pulley, the driving wheel, and it has 2 set screws here. So I've filed gentle flats on 90 degrees apart from each other, so that's what those set screws will rest on. So I'll go ahead and slide it down first. Should be plenty tight. Set that down. Next will be the right side bearing. Okay, so this bearing next. Just changing direction so that the painted side is out. I should also mention that these bearings, after I poured them and took the paper out, whatever, from the shaft, I took an angled chisel and carved an oil groove in the top. So there's a hole that goes through here, and then there's an oil groove that goes about 1 inch on either side out from that hole, so that when the oil goes in, it can spread across the top surface of the bearing and then be drawn around the whole thing. After that, took the good old scraping tool, got any burrs off, and that's where we are now. So that's that. I think I will put, the collar should go here because this cross piece is what's fixed. This one can move, so yes, the collar should go next. There's that, and now come the tight and loose pulleys. The tight one will be on the inside, the loose one will be on the outside so that it can go against the bearing. And the tight pulley will limit it on one side, the bearing will limit it on the other. Just have to align the two centers because they're not quite symmetric. One side's inset, the other side's out. So that kind of funny too because each one is opposite with regards to the curve of the spokes. Anyway, go like that. Then comes the next bearing, the left bearing. So there we go. This assembly, no, it's not as heavy as I expected. It's probably in the 40 pound range. So just adjust the camera and throw it up there, see what happens. Oof. 40 pounds on the ground is one thing. 40 pounds in the sky is another. Okay, what shall I do here? I think I'll hook it on the far side and then hoist it over. Come on. Oh, set screws in the way. that. Okay, oil hole up. This goes like so. Bearing in. Oh, I need a wrench for that set screw. Okay, shift right over like so. Okay, first look, everything is good. First check, nothing's interfering. Let's grab the wrench to play with the set screws. Last one. There we go. Whew. Time to take off a couple layers. My. Well, how does she look? I'd say not so bad. Whew. Alignment is a little bit off, but no problem. This grinder can move 5 or 6 inches to the right. I'll get the set screw for this guy here. Adjust it. This is reasonable protrusion. Oh, the collar goes there. This is the limiter. Okay. Next thing is the shifting rod, and it will, I'm pressed. Oh, it's 9 o'clock. The shifting rod will clear this pulley, which is a pleasant surprise, unexpected, which means the shift lever could go on this side, but it will then be blocking my most lovely sounding clock, so I think I'll stick with it on this side, but maybe set the angle differently than that of the lathe. The forks are made with a bit of a round on the inside. There's a round on the side that is meant to interact with the belt, and then either a flat or a curve on the opposite side. So these two round sides go inwards, and on this set of forks you can see they were used significantly. This one was even built up with braze at one point, it wore so much. But from the belt, just running on the edge of it, it wore right through the cast iron. Pretty impressive. That's a solid 1/16 of an inch anyway, the belt wore through. Shift this over. Fork 1, fork 2, collar 1, collar 2, go on the outside. Oh, collar 2 clear the belt? Yes, it will. Okay, and this connector will go over here. So that will be in the idle position, and then the drive position will be about. I've done a rough calculation with the size of pulley that I align on the main shaft for this. We should end up getting around 2,500 RPM. If that's not adequate for these, what are these, 8-inch stones, then we'll bump it up a size on the main line, no big deal. All right, so same as what you saw before. I've gone ahead and added this shifter. Because it kind of tapered to a pin at the end, I just took a piece of pine, a 2x6 section, and drilled a hole in the center and bolted the whole thing to the roof. So there's a little bit of slop in it, but it does what it needs to do. These two collars are the limiters, and these are the belt guides. So I dug through all the belts, found a section that will run from the driving wheel to the grinder here. It's quite a thick belt, a 4-ply rubber impregnated canvas, and the belt from the line shaft to the countershaft, thanks to JR, is this 2-inch rolled type belt. So it has a seam on the outside, has a good solid edge, which is great for shifting. So a little bit moldy, but no problem, that'll wear off soon enough. So I will go ahead. It has a maker mark on it, but I can't quite make this one out. I believe it says Toronto. This other one here is a very nice condition maker's mark of Monarch Hewitt, Buffalo, New York. So that's a kind of neat one. Now let me do this one first here. I have the pin. So I'll just connect it when it's off that pulley. One of the original lacings is still on here. It's has the same pitch as clipper, but it has a metal reinforcement, and then the top part here I redid with modern clipper lacing. So I'll go ahead and come on. There we go. Look at that. Smooth, smooth, smooth. A little bit of slippage there when I propelled it, so we'll get the dressing to it and it'll be no problem. Get this lad. Make sure the seam is on the outside so that it lasts. Wear out that seam. And so the grinder, the main line runs, from my perspective, clockwise. The grinder runs counterclockwise. So this is the belt that I'll put a half twist in. The belt that runs the grinder runs a lot faster, so I decided it'd be better to put a half twist on this one. So whoop, flip it around over there. Grab the pin. There we go. Make sure that's fit in the forks, and then I'll run it onto this pulley. It's driving right now, so I'll just kind of move it as I, whoops, wrong one, move the shifter. And we'll get it over onto the idling wheel. There. There it is. I already see it needs to be adjusted a little bit. This one shift fork needs to move over ever so slightly, just so that it doesn't rub on the tight pulley. So I'll go ahead and belt up the motor and get ready with some belt dressing, as well as hit the countershaft with some oil. As well as the idling pulley. Need to find the hole there for the what used to have a set screw, which will be the oiling hole in this case. I have some good old-fashioned belt dressing in the tube. This is really hard to find. I don't know if they make it at all anymore, or if you can only get the old stuff. Anyway, I have a little bit of that. It's almost like peanut butter. When it's warm, it's like peanut butter, and when it's cold, it's like this taffy that's just kind of fibrous. And anyway, it does a real good job. So we'll get this running and see. Add a little bit of it, make some dust. That should be just fine. Okay. Yeah, let's fire up. Wow. Oh, geez. Ugh. Yeah, let's get the mold off that one. Oh, did you hear that? You can hear it grabbing on that pulley. There's a little bit of this stuff. Wow. Okay, well, see what happens. Oh, a little bit of rubbing from this collar. I hope that wouldn't happen, but it is happening, so. There we go. Sounds reasonably smooth. There is a little bit of chatter. I have to tighten the bearings. Let's try. See how it is. Maybe it's just that the wheels are out of round a little bit. Good thing we have the tool for that. Well, not so bad. Not so bad at all. And just put a little bit of dressing on this belt here. And the motor drive belt, it wouldn't hurt to have some. Go ahead and add a little bit of oil to the grinder bearings. I'll need to either take some material off that collar there or move this pair of collars to this countershaft hanger here. That's pretty good. This belt is tracking well. This pulley could move over maybe an inch or inch and a half from the line. Disconnect it. Yeah, so the driving pulley on the line shaft could move over. Slow down. Whoa. Okay. I think it's wanting to pull to that side because of where this pulley is. So this, I'll move this whole pulley over. Alternative would be to move the shift lever, but in this case, we better move the pulley. Fire it up one more time. That takes some power. Not so bad. Not so bad at all. Well, hope you enjoyed this round of line shaft machine shop activity, and let me know what you liked. Also, a big thank you to the special someone who got me this wireless microphone, and I've had lots of comments on not being able to be heard properly, so that should improve that. Let me know what you think. Lots of more projects, lots, all kinds of stuff to go on, so stay tuned. Till then, have a good one.